In this video, we'll be solving a question from the Nelson Physics 12 textbook, and that's going to be page 103, number 47. In this question, we have three masses which are connected by strings, and we are to assume that the strings themselves have negligible mass. We are to calculate the tension in the strings and the acceleration of each mass. So we'll start off this problem just like we would any other one. We'll list our givens. And we have here our mass 1, our mass 2, and our mass 3 values, 6 kilograms, 4 kilograms, and 3 kilograms. We also have our acceleration due to gravity, which is going to be 9.81 meters per second squared. Now, what's our required? What are we looking for? We're looking for the tension in the strings and the acceleration. Well, let's talk about acceleration for a bit. So it's asking us for the acceleration of each mass, but we see here that the masses are all connected. So this means that all the acceleration values are going to be the same. So instead of A1, A2, A3, we're just going to have A. It's going to be the same for all of them. And so we're going to try to find A. And we have two strings for tension. That's string A and string B. So we'll have the force of tension in string A and the force of tension in string B. Now, how do we start to solve this? Well, we can kind of see that we're dealing with forces, masses, and acceleration. And we can kind of sum it up with Newton's second law, or rather create a relationship with Newton's second law, and that's F equals ma. The vector sum of all the forces on an object is equal to the mass of the object multiplied by the acceleration of the object. And what we're going to do with this is actually we're going to create three equations using this formula, and we're going to combine them together, or rather add them up, in order to solve for our acceleration. And so before we actually create our equations, let's look at our free body diagrams. So we have all our forces laid out for us that are relevant, because these are the only ones acting upon the object that we're looking at. For mass 1, we have the force of tension A provided by string A, and the force of gravity downwards on it. For mass 2, we have the force of tension A, which is going to be provided by string A, and downwards we have the force of gravity on it, plus the force of tension B, which is also here. And for mass 3, we're going to have the force of tension B upwards, provided by string B, and the force of gravity downwards acting upon mass 3. Now, with these equations, with these free body diagrams and our diagram over here, we can actually create our equations right away. But before we do that, let's determine our positive direction. In this case, I'm going to say the positive direction is anything that kind of moves the masses in a clockwise direction around the pulley. Or rather, when any force that causes the right side to move downwards and the left side to move upwards, kind of like this. Negative would be the other way. And so that means for mass 1, FTA, which pulls it upwards, is going to be positive, while M1G, which pulls it downwards, is going to be negative. And right here we have our equation 1. FTA minus M1G equals M1A. And that is going to be following this because MA is on the right side and we have M1A. For equation 2, we have, let's move everything upwards. We're going to have FTA, and it's actually going to be our positive direction for M2 is going to be downwards, so any force downwards, M2G plus FTB is positive, while FTA is negative. And that is our equation 2. M2G plus FTB minus FTA equals M2A. And our last one is also going to be, downwards is going to be the positive direction, and we have M3G, what's up? M3G minus FTB equals M3A. Now, we have all three of our equations, and now we actually just have to add them together or combine them. But wait, let's simplify it a bit actually. If we were to combine this just means that we're adding all the left sides together and we're adding all the right sides together. On the left side actually, we have our forces provided by tension which cancel each other out. We see here FTA here, but we have a negative FTA here. So actually, this is going to cancel out with this one. And same with FTB here. This FTB is positive, this FTB is negative. So when we combine them together, what we're going to have is actually M1G, or negative M1G plus m2g plus m3g equals m1a plus m2a plus m3a. You may have seen the next step, but since we're solving for a, we can actually just kind of simplify it really quick by factoring out our g from the left side and our a from the right side. And to isolate for a, we're just going to move this over here by dividing both sides by this. This will cancel out and this will end up at the bottom. And you can kind of rewrite it. It's going to be our acceleration equals negative mass 1 plus mass 2 plus mass 3 multiplied by gravity divided by mass 1, mass 2, and mass 3. Or the sum of mass 1, mass 2, and mass 3. And, well, what do we do next? We just plug in our numbers, actually. We can look from our givens that we actually have all the information we need. We have mass 1, mass 2, and mass 3. So, we also have our force, our acceleration due to gravity, so why not just plug in our numbers? We plug it in, and this is what we get. We get our dimensional analysis works well because our kilograms cancel out, they cancel out, and we're left with meters per second squared, and so that's the unit for acceleration. And we're rounding to 0.75 for our final answer for acceleration because of our significant figures. Well, that's our answer for part 1. This is the acceleration in the system. This is the acceleration for each mass, rather. But the question also asks us to calculate the tension found in each string. So to do this, actually, it's rather simple. Because we know our acceleration now of the system, we can just look back at our equations. We'll look at equation 1 to solve for string of tension A. And that is, if you remember, FTA minus M1G equals M1A. We can rearrange to solve for FTA, and that's going to be FTA equals M1G plus M1A. And since we know the values for M1, we know the value for G, we know the value for M1, we know the value for A, we just need to plug in our numbers. Plug in our calculator, and there we have it. And it's newtons because kilograms, meters per square per second squared is going to be a newton. And so that is going to be our force of tension A, 63 newtons. For our force of tension B, we'll use equation number 3, which is going to be m3g plus minus ftb equals m3a. And that is going to be rearranged ftb equals m3g minus m3a. We know all the values, we just need to plug in our numbers. Plug into our calculator and solve. Remember, 2 sig figs for both FTA and FTB because we're accounting for our significant digits. And so our final answer is going to be the acceleration on each object is 0.75 meters per second squared. Our tension in string A is 63 newtons and our tension in string B is 27 newtons.